Okay, so now in this video, we're going to continue on the concepts. And so we already covered the what is the class, what is the object. Now the next question is what is the inheritance? Or we also sometimes refer to it as generalization. And so we want to see what does that mean. So sometimes we have different kind of the same object, right? So for example, we have a class of object animals, right? So it's very abstract, right? And then we have a lot of different kind of animals, right? We have dogs and cats and so on and so forth. And then even in the dog, we have a lot of different class of dogs, right? So we have, I don't know, German Shepherd, blah, blah, blah. I don't know all of them, but like Golden Retriever, whatever, right? So those are going to be like other classes, right? So even in that sense, dog itself become very abstract because we have different kind of dogs. Same thing for cats, right? We have Persian cats and we have different kind of cats, right? So even cats, it's become very abstract, but they're all animals, right? So they're all going to be in the class of animals. So when we have this, we're going to use this idea, using this categorization and classification idea into our programming, and that helps our programs to be basically easier again to understand, because what you're going to do is you're going to put everything related to all the animals in the world that the common between all of them into the animal class. Then we get to the dog. We already inherit everything that we had in the animal. We're only going to add things that related specifically to only dogs. And it's common between all different kind of dogs, right? It doesn't matter if the German Shepherd or is a golden retriever. All of those dogs going to have same estate and same behavior. So we don't have to repeat things that it's already in the animal, right? Because we already put everything common between all the animals inside the animal class. We're only going to add things that is specific to dog, right? And common between all the dogs in the dog class. The dog itself automatically going to inherit everything from the animal first, then also on top of that is going to have a specific things that's related to the dog only. And then when we get to the cat, same thing's going to happen. Cat is going to inherit everything that's common between all the animals, and cat is part of it. And then on the top of that, you're going to put a specific things related to the cat that's common between all the cats only inside the cat. So you don't have to repeat your whatever you said already inside the animal, right? It's already going to be inherited. And then you add a specific things inside your cat. And then when you go to Persian cats, then you're going to see everything is only related to Persian cat if there is any specific things. And the Persian cat automatically is a cat because it's inside a class of cats, and automatically is an animal because cats are animal. So the Persian cat not only going to have inherit everything that cats does, it's also inherit everything that animal does automatically. So it's kind of, you're going to inherit everything that's your the classes that are superior to you, like so more abstract classes, you're going to inherit everything from them. So how we do that in a Java, we use extends keywords, right? So basically, for example, when I created the dog class, and I know dog is going to inherit from animal class, then when I create the dog class, I'm going to say dog class dog extends animal. Or when I create a cat class, then I'm going to say class cat extend animals. And when I create the Persian cat, then I'm going to say class Persian cat extend cat. So that's a limitation in Java. You cannot do another extension. You only can extend from one class, right? So Persian cat only can extend from the cat. But the cat is already extend animal. So automatically Persian cat extend the animal, but you cannot write it like that. Like you cannot say class Persian cat extends animal comma cat. You cannot do that. That's wrong, right? So that's a limitation in the Java language in some sense, that's you only can inherit from one object at a time. and you cannot inherit from two objects. So there is another way to do that. We call it, we're going to see that in the next slide, and that's called using interfaces, right? So if you have multiple classes that you're trying to inherit from them, those other classes should have interfaces, and you're going to inherit from their interfaces. We're going to talk about that, and that's called implements, right? So you're not extending anymore because you're only allowed to extend from one class, but you can implement multiple different interfaces. So that's how that limitation solved in this language. But again, we're not specifically talking about Java, right? Programming languages that using object-oriented concepts is going to have to implement all of these concepts somehow, right? This is how Java implement that. So the Java implementation of inheritance is that, okay, you only can extend from one class at a time. And so if you want to extend from multiple class, because the concept would allow you to do that, right? Just Java has limitations. So to solve that problem, Java said, okay, you can use the inheritance concepts with using interfaces, right? So that's how they implement the other part of it, basically. So this is how we're showing that in UML diagram. And there is a very important rule for it. So when you're using inheritance, there should be very strong is-a relations between your objects. I only can extend from animal if I'm an animal, right? Only cat can extend the animal class. A car cannot extend animal because car is not an animal, right? There should be very strong is-a relations between your objects when you're trying to use the inheritance and extend keyword. So here I have example of bicycle. Mountain bike is a bicycle. If this statement is correct, then you identify your inheritance correctly. But if there is a wrong statement here, like for example, car is a bicycle, or dog is a bicycle. So I'm trying to inherit from bicycle, although I'm a dog, I'm a completely different class of object. That is a wrong way to use inheritance. And unfortunately, you sometimes you're looking at people codes and you see that kind of things, right? So you're extending a class of object that has nothing to do with your class. And then when you really going to talk to the programmer, that's why, what is your logic behind this extension, behind using this inheritance, you kind of see that, okay, there is one single particular behavior in this bicycle that also my dog is going to do the same thing. And so I'm just make that inheritance happen so I can use that class behavior. And that's wrong way to use it. That makes your code more basically complicated, more harder to understand, more harder to change, because there's no logical understanding. There's no logical organization. Now you're having a two completely separate class of objects, and then you let them talk to each other. Like if I have a car and I let the car talk to animal, right? Or inherit from animal. That's like completely there's no logic behind it, right? So that's why it's important to understand why we have extension, what does that mean, inheritance, and those kind of things, so you can use it correctly. Because if you really use it correctly, it's really helps your classes and your design overall become really easy to understand, easy to change. So is-a rule is a very important rule whenever we're talking about inheritance, right? And that's how you know if you identified in inheritance correctly or not. It doesn't make sense. So when we're talking about inheritance or generalization particularly, you want to make sure that this is-a relation is a very strong relation, right? So it should be really, they should be really same kind of object. So then you can use inheritance for them. And this is how we show that, by the way, this is how we show the inheritance in the UML diagram. As you see, it's kind of like a triangle, and this triangle that's empty, it's white, basically a triangle, pointing to your superclass, right? So bicycle here is my superclass, or in the example of animal, animal is my superclass, and the cat and dogs are subclasses of animal. Those subclasses are going to extend from the superclass, and that therefore the relation in the UML diagram is from subclasses to the superclass. So the pointer, or the arrows of the triangle, the point of the triangle is pointing to the superclass. And it's important to follow these rules of UML diagram correctly. If I do it completely opposite, right, I show that from the bicycle to the mountain bike, then that tells me the mountain bikes is actually my superclass. And so whoever is going to program this is going to get completely confused, right? So it's very important that when you're using UML diagram, you're going to visualize your design. That's the main concept behind UML diagram, Unified Modeling Language. You're trying to model this, visualize things that it's in your mind, your design, right? So visualizing your design, and then you're doing it correctly, then converting that design, converting that model to a code is a mechanical job. You do all the thinking, then you come up with your model, right? And you draw the model with the model language such as UML. Then you can let the tools now, other tools, because that's a mechanical job, converting this diagram to a code, right? So that's why the diagrams are important. If you use them correctly, they're going to help us a lot as far as making things happen fast. You do all the thinking and you draw diagrams. Somebody else is going to take care of the coding part. So now what is interface, right? We already talked about inheritance, and we talk about how we're going to do that and all of those things, and when and how the interface come to the picture. So interfaces are basically the methods that, or the public methods that helps your objects to talk to outside of the world, right? To other objects. You're hiding everything behind these methods. You're protecting your data behind all of these, so you don't let people directly go and change your data. So you only, if they want to make any changes or their requests or need something, they have to go to your interfaces, which is your methods, right? So interfaces are basically going to be considered as a group of related methods. And we can actually create an interface as an object types, kind of like as a class. It's basically like we have a class type and we have interface type. So you can create that. So this is how we're creating interfaces in Java. You're using the interface keyword and you're using the name of your interface. And then you put all the methods. So here is all different kind of methods that you can add here. And those methods are having empty bodies, completely no implementation. They're all public abstract methods. There's no implementation in them. And then whoever implementing this interface has to implement all of these methods as well. So the limitation that we had, that we can only extend from one class, we don't have that limitation anymore. You can extend from one class and you can implement multiple different interfaces. So that way it feels like you can, inherit multiple different behaviors from multiple classes. So the rule to identify if you're identifying your interface relation, or we call it implementation interface, correctly or not, is same as the inheritance, because you still inherit, right? You inherit those behaviors, but the relation still a relation, like it's still bicycle is washable, for example. So you can wash your bicycles, and there is a method here how to wash that helps you to, to know exactly how you're going to wash your bicycle. But as you can see, washables, although you have a class of kind of everything in the world that are washable, you have to know how to wash them, right? So it's kind of like more general, right? So there are lots of different class of objects that can be washable. You can have all this class of cars that are washable. You can have all this class of bicycles that are washable. You can have all this class of windows that are washable, and even you can have animals that are washable, or fruits class that are washable, right? So the washable is going to be more general. So there still is a relation, but there is a relation that we have in interfaces is not as strong as is a relation that we have between inside the inheritance using the extents, right? So when you're use inheritance between the classes, it has to be very strong is a relation between them. But when you're doing inheritance from interfaces, then that is the relation can be a little weak. It doesn't have to be that strong, right? But it still should make sense, right? Is bicycle washable object? Yes. So then this is a correct way to use the inheritance, right, in this case. So you still basically inherit from washable, but instead of inheriting those, there's no data field to inherit, there's no state to inherit. Whatever you inherit is just some behavior, right, and some methods. So that's why we're showing it using implements keyword. And the drawing diagram for it, right, is different also. The notation we're using for implements, it's instead of a solid line and a triangle on the top, is going to be dotted line and a triangle on the top. So this is how we're going to write this. I have this interface washable, and I have this class bicycle that implements washable. All right. So the mountain box class mountain box is going to extend bicycle, and automatically it's going to also extend washable, right? It's kind of you're not directly inheriting it, but you're inheriting it through bicycle. Why? Because mountain bike is a bicycle and bicycle is washable. So mountain bikes are washable too. So however, we are implementing the how to wash method inside the bicycle, that is going to be inherited to the mountain bike as well. So we're going to talk about concepts of overriding later on. And so, for example, if there is a specific way to wash the mountain bike, it's different from washing other types of bike, then you can override this how to wash method inside the mountain bike and change the implementation of it, basically. So because this is a different way that you're washing this, so you need to know the difference. So the how to wash method is going to be implemented differently inside the mountain bike. So whenever you create an instance of the mountain bike and you're calling how to wash method of it, that particular implementation is going to be called. Here we're going to talk about all of those concepts as well. This is just an overview, and I'm sure some of you are already familiar with these concepts because it's very similar to C++. And the reason is the object-oriented concepts are the same. They're just the implementation of them in the different languages are a little bit different from each other. And we just want to know exactly how Java implements that. We're going to do it with different examples, and we're mainly going to work on our tic-tac-toe game. So we're going to apply all of these concepts into our tic-tac-toe as we're learning them in more details. The last things I'm going to talk about it is going to be what is a package, right? So as we keep generating different class of objects and we let them maybe talk to each other or not, we notice that we're going to have a lot of classes that they may not be completely related to each other. And then we have some classes that, although they're talking about different objects, but they're really related to the same things, right? Back to the kitchen and the house concepts, right? There are lots of objects inside the kitchen, right? And there are lots of objects that belong to the closet and in the rooms in the house, for example, or different rooms like living rooms or dining rooms, stuff like that, right? So whenever you have this many objects inside your house application software, then you have to have a very good way to organize them, because you cannot just put all of these classes back to back. It's hard to again follow. It's not organized enough. So how we're going to do that? We're going to create the packages. Packages are basically like folders, when inside your computer. Similar things, you're creating different packages inside your applications. So everything related to the kitchen, now all the objects you identify for the kitchen is going to go to the package kitchen. And all the objects related to the living room is going to go to the package living room and stuff like that. So that way you're organizing things, not only that they're going to be in the separate objects, right? Each object is going to be specific to particular things, but also you're organizing within the packages as well. So another layer of organizations whenever you have a lot of different objects. And again, back to the fact that we talk about the mass productions. So since we do mass production, our applications are huge, and we're going to use huge number of objects. So it's very important to try our best to organize it as much as we can. So using packages and organizing things in a different package, it's another attempt to organize them. And so Java platform, you hear a lot of these concepts of API, using API, and you sometimes feel like, okay, what is this API? So APIs is a short way to say application programming interface. And so these interfaces inside the Java platform is going to have a lot of different packages in them that, is going to help you to do different things. So basically, it's kind of like libraries that they're already implemented for you to do different things without rewriting them again. So these are reusable libraries that you don't have to implement them again and again and again. You just can use the library in API provided by the Java platform and be able to basically use inside your design. And how we show them in the UML diagram. This is how we show the packages. So it's kind of like look like a folder again, as you can see. And here I have multiple different package. I have a package that is part of my model and showing the layer application that I have, different layers of my application overall. Then I have, here I show 2 layers at least. We can have up to 7 layers maybe or more, depends on how big your application is. So one package or one layer of this application only focus on things related to the UI or user interface, or we call it presentation layer. And another one is going to focus on the business layer, right? The everything related to the application and all of the processes happening inside it. And so as you can see, these packages, sometimes they should, or they talk to each other as well, right? So there should be some sort of a dependency between them. So dependencies, as you can see in the UML diagram, they kind of look like a dotted line with an arrow on the top. That's basically a can stick arrow. It's nothing in it. And it's not like a triangle or anything like that. It's not a solid arrow. It's just a stick arrow, like, with a dotted line. And that is called dependency. And that shows that probably one of my classes inside this package is calling another class inside my business layer. So that shows the dependency. So this is the package diagram that we can draw whenever your application get really big inside our in the UML diagram as well, to show the organization and how we organized different part of our application. So I use this different sources, also the book, also a little bit talking about some of these concepts. So you can also go directly to this, and if you want to read more or know more. But in the next few chapters, and next few modules, or basically, or I have to say, in one big module, we're going to talking about all of these object-oriented concepts and how we modular our code using the classes, and using the abstract classes or not, or we're using interfaces, and what is the difference between abstract classes and interfaces, and so on and so forth. And then we're talking a lot about polymorphism, which is a very important concept. And if you have inheritance, you can use polymorphism. I'm going to talk about that. Method overriding, method overloading, what is the difference between those. So there are lots of keywords and lots of concepts that we're going to talk about them in next few modules. Okay, bye for now.